This lesson is 10-8, probability of compound events. In the past, we talked about simple events, which means just doing one thing, rolling a dice, spinning a spinner, picking one thing. But today is compound events, and that means that this is two or more simple events together. So maybe it's rolling a die and spinning a spinner, or maybe it's pulling out something from a bag and rolling a dice. So what the probability is of doing two things together at the same time. So we can use a few different things for this. We can use tree diagrams, we can use the fundamental counting principle, and the other thing I'm going to talk about is using a table. I don't have this in my list, but I'm going to talk about how to use a table. And then sample space is all the possible outcomes. So like having a visual of all the possible outcomes that you could have. Now you don't always need sample space, but sometimes it's going to ask you for the sample space. And when you need sample space, most likely you're going to use one of these two things. Either the tree diagram or the table will help you show sample space. The first thing we're going to talk about is we're just going to kind of go down the list. And the first thing I'm going to talk about is the tree diagram. So I'm going to go back here. I think I'm ahead. Okay, well, you can choose between an apple and pretzels for snack. You can also choose between lemonade, water, or milk for a drink. How many possibilities or sample space are there? And what is the probability of you picking an apple and lemonade? So first thing we're going to do is we're going to talk about the apple and the pretzels. So I can have an apple and pretzels. Okay, and now let's talk about what we can have to drink. So we can have an apple and lemonade. We can have an apple and water. And we can have an apple and milk. Same thing with the pretzels. We can have pretzels and lemonade. We can have pretzels and water. And we can have pretzels and milk. So there's my sample space. So really, to list my sample space, I should do something like this. Apple, lemonade, apple, water. So this is technically my sample space. Apple, milk. We can have pretzels, lemonade, pretzels, and water, and pretzels, and milk. So this is my sample space right here. Now the question is, what is the probability of you picking an apple and lemonade? So if I look at here, how many possibilities do I have? I have 1, 2, 3, 4, 5, 6. I have 6 possibilities. And the probability of me picking an apple and lemonade is 1 out of 6. So this is my sample space. So when they ask for sample space, you need to have an actual visual of what you can have. And then sometimes they might ask you for the probability of something in your sample space. So let's try another one. This is make a tree diagram and find the sample space. So I'll do this one with you too, because sometimes when we have 3 possibilities, it gets a little trickier. So let's start with a hamburger and pizza. So we can have a hamburger and we can have pizza. Now let's talk about a dessert. We could have hamburger and chips. And we could have hamburger and cookies. And we could have pizza and chips. We could also have pizza and cookies. Now, we can also have water and pop as a drink. So you could have a hamburger, chips, and water. You could also have hamburger, chips, and a drink. You could have hamburger, cookies, and water. You could have hamburger, cookies, and I'm sorry, this was supposed to be pop. Pop. Hamburger, cookies, and pop. You could have pizza, chips, and water. You could have pizza, chips, and pop. You could have pizza, cookies, and water. You could have pizza, cookies, and pop. So how many possibilities do I have here? So I have, this is 1, this would be 2. And the reason why I say that that's 1 and 2, because hamburger, chips, and water is 1. Hamburger, chips, and pop is 2. Hamburger, cookies, and water is the 3rd possibility. Hamburger, cookies, and pop is the 4th. Pizza, chips, and water is the 5th. Pizza, chips, and pop is the 6th. Pizza, cookies, and water is the 7th. Pizza, cookies, and pop is the 8th. So I have 8 possible things that I could have. Now, if I asked you for what is the probability of me having pizza, chips, and water, here's my pizza, chips, and water. I have 8 possibilities, but only one will be pizza, chips, and water. So that's how you do a tree diagram. You have to make sure that you get everything in there. You know, sometimes people get messed up on that third one, but you have to make sure that you include those two things together out of the chips. You can't just put pizza, hamburger, chips, and water because you can also have hamburger, chips, and pop. So a lot of times people will get confused in that third step. So careful there. The next thing I want to talk about is the fundamental counting principle. Now this is the only time you can use the fundamental counting principle, and it's when you just need to know how many possibilities there are. And maybe they don't ask for sample space, they just want to know how many possibilities there are. So if I have 10 choices of appetizer, 3 choices of main course, 2 choices of dessert, I want to know how many possibilities there are. Now, if I would make this tree diagram, it would be huge. Now, a tree diagram could work for this, but there's also a different way to solve this if you just want to know the possibility. And this is very simple. You would take your choice of appetizers times your choice of main course times your 2 things of dessert, and multiplying all those together, I already know that there's going to be 60 possibilities. So my tree diagram would actually be really, really big because I'd have to have 60 different possibilities in there. So all I have to do when I ask for possibilities, I just multiply them all together. That's all it takes. Now, it depends kind of what they're asking. If they're asking for the sample space, then you have to make a tree diagram or a table. But if they're just asking for how many possibilities, you can use this. Here's another example. If I have 4 choices of bread, 5 choices of meat, and 6 choices of sauce, I take my bread times my meat times my sauce, and I multiply them together. Let's see, 4 times 5 is 20. 20 times 6 is 120. Now, I could make a tree diagram for this, but seriously, look how big it turns out to be in the end. So I'd have 120 possibilities. So my tree diagram would be huge. It doesn't look like it would be huge, but it would be fairly big. So this is the only time you can use that, and that's when they ask for how many possibilities there are, and there's nothing else that they ask. All right, so here's some other types of compound events. So maybe it's when you have 2 different things happening. You're throwing a dice and you're spinning a spinner. So this is how the probability will look. I'll say P, probability of rolling a 3 and spinning an orange. You see I have 2 different things in the probability. So first thing I'm going to do is I'm going to look at rolling a 3. So if I look at my dice, what's the probability of me rolling a 3? I hope you said in your head 1 out of 6 because I have 6 possibilities on that dice, but there's 1 3. Okay, so that's me rolling a 3. Now, what's my probability of me spinning an orange on this spinner? Right here, I hope you said 1 out of 4. Now, I'm going to take those 2 things and I'm going to multiply them, and I get 1 out of 24. That means I have a 1 out of 24 chance of rolling a 3 and spinning a spinner. Meaning that if I would spin my dice or spin my spinner and roll my dice together 24 times, I have about 1 chance of it landing on 3 and orange at the same time. All right, so my next one is the probability of an even number and spinning a blue. So first of all, let's talk about your even number. So on my dice, I have a 3 out of 6 chance of getting an even because 2, 4, and 6 are even. So I have about 1/2. I'm just going to reduce my fraction. And me spinning a blue, I think I only have 1 blue up here, and I think this is it. So 1 out of 4 chance of spinning a blue. Altogether, I have a 1/8 chance of rolling even and spinning a blue. So these are just other types of compound events. I could think of another type. So let me do another type like this. So let's say, what's the probability, and we're just going to change gears here, of flipping a heads on a coin and then flipping another heads. So, okay, what's my probability of getting heads on a quarter? It's 1 out of 2. What's my probability of flipping my quarter again and getting a heads? It's 1 out of 2. It's 1 out of 2. Shoot. Okay, let's try this again. So altogether, if I want a heads and a heads, I have a 1 out of 4 chance of flipping a heads and a heads on 2 quarters, or 2 dimes, or 2 nickels, or a coin of any sort. So let's go back to the top, and let's look at our spinner and our dice again. So what's my probability of getting a purple on my spinner and flipping a heads on a quarter? So my purple would be 1 out of 4. My heads is 1 out of 2. Altogether, I have a 1 out of 8 chance of spinning a purple and flipping a heads on a quarter. So just doing them separately and then multiplying together is a way to easily do compound events if you have two totally different things. All right, so the second last thing I want to talk about is a permutation. This is another type of probability that has compound events with it. And if 7 students are running a race and only 3 can medal, how many possibilities are there in the race? So this kind of goes really, really well with track. So I have 7 students running a race and 3 are going to medal. These are my medal spots. This is going to be my first place, this is going to be my second place, and this is going to be my third place. So in that race, how many possible kids can get first place? 7. I know there's 7 possible kids that can get first place. Now, 1 gets first place. How many kids can get second place? 6. 6 kids can get second place because there's still 6 running that race. Now, let's say I have a first and a second place finisher. Well, how many kids can get third place then? How many left could possibly end up with third place? 5. So 7 times 6 times 5 tells me how many ways that these 7 kids can line up in first, second, and third place. 7 times 6 times 5, 210 ways that these kids can line up first, second, and third, and that's only 7 kids running that race. Here's another problem. If you need a 3-digit code to get into your house and you can only use numbers 1 through 9, you can't use the same number more than once, how many possible codes are there? So first of all, before we talk, between 0 and 9, this is 10 numbers. 10 numbers are between 0 and 9. So I'm going to first say I have 3 digits, okay? And my first digit, it says I can't use the same number more than once. So that means I can't use like all 4s or all 2s. I can only use them one time. So in my first spot, how many possible numbers do I have to pick from? Well, 0 through 9, I have 10 numbers, okay? My second spot, I have only 9 possibilities because let's say I used a number in my first, I can't reuse it again. So I have 9 possibles left for my second spot. For my third spot, I only have 8 numbers left over because I used 2 in the front. So 10 times 9 times 8 is 720. That means I have 720 ways that I can create a 3-digit code to get into my house. And a lot of times it's 4 digits. So if I had another digit and I couldn't use it, it'd be times 7. So that's this many possibilities. For the most part, let's say if we have a phone code, let's say your phone code can be 0 through 9. And usually it's 4 digits. And you can use it as many times as you want. So in the first space, I have 10 possible digits. For the second space, I have 10 possible, because you can continue to use the same number over and over again. Third digit, I could use 10. I have 10 different numbers. The fourth digit, I can use 10 different numbers. If I multiply those times each other, there are 10,000 possible different numbers I can use for the code on my phone or on a door. That's if you can reuse digits over and over again. So knowing the situation will depend on what you could put on your first, second, and third digit, and maybe fourth. All right, the last thing I want to show you is how to use a table. So let's say I want to know the probability of rolling 2 1s. Okay, so the probability of, or I could say, because I think I talked about Monopoly, I want to know the probability of rolling doubles on 2 dice. So this is how you could make up a table. So let's say my first dice goes this way. Okay, I have 6 possible ways for my first dice. And the second, I also have 6 possible. And I'm going to move him down a little bit. There we go. Okay. So I'm going to start kind of making a table, and I can see all my sample space. So I'm going to start with my top row. And so my first could be 1, 1. I could have 2, 1. I could have 3, 1. I could have 4, 1. I could roll a 5 and a 1, and I could roll a 6 and a 1. Now I'm going to continue with my top one first. I could get a 1 and a 2. I could get a 2 and a 2. I could get a 3 and a 2. 4 and a 2. 5 and a 2. 6 and a 2. Now you just continue to fill up your table. So I could get 1 and a 3. I could get 2 and a 3. 3 and a 3. 4 and a 3, 5 and a 3, 6 and a 3. See how I continue making my table. And I'm just going to keep going here. Oh, I'm sorry. Oh, yeah, that was right. 2, 5, 3, 5, 4, 5, 5, 5, 6, 5. And then I have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. All right, so I have my whole table filled up. I can see all my sample space. So I want to know the probability of me rolling doubles. Well, here are all my doubles. Okay, and how many possibilities do I have of roll? Well, I know I have 36 possibilities because I have 36 6 rows and 6 columns, so I have 36 possibilities. My probability of rolling doubles, well, how many doubles do I have? 1, 2, 3, 4, 5, 6. 6 out of 36, which will reduce to 1, 6. So I have a 1/6 chance of rolling doubles in a game. So this is how you use a table. A lot of times it works really easy if you're going to use dice or anything, knowing what you need to roll. Another way this can be used is like, what's my probability of rolling a sum of 5? And then you can find your sums of 5 and you can add them together and figure out how many probabilities. So you can use dice tables very, very easily to answer a lot of questions. So if you have any questions, let me know. I hope you took some good notes, and we'll talk a little bit more about compound events in the next time in class. Thanks for watching.